What is going on, everybody, and welcome to the Postmortem for my Ludum Dare 43 Game Jam game, which I called Tetrifice. So if you're unfamiliar with Ludum Dare, it's essentially a game jam that takes place over the course of a weekend. There are two different competitions that you can enter. One is the 48-hour game jam, which is a little bit more difficult because you have to do everything yourself within that 48-hour time period. And that's referred to as the compo jam, which is the one that I always participate in. And then there's just kind of the general game jam, which is over the course of 3 days. So you have 72 hours to make your game. And in that one, it's a little bit more relaxed because you can work with a team of people. And you can use, pre-existing art assets that you find on the internet or things that you've already created in the past. And so for this game jam, at the start of it, there's always a theme that's announced. So for this game jam, the theme was "Sacrifices Must Be Made." And as you can imagine, lots of people came up with lots of wacky ideas about sacrifice and putting it into their game somehow. For me, I kind of wanted to make something a little bit more puzzly. So I combined Tetris with sacrifice, so hence the name of my game, Tetrifice. Now the basic idea of Tetrifice is you basically just play Tetris as normal, and every once in a while the game will ask you to sacrifice one of your pieces. And so you basically have to click a piece to sacrifice, and then all the pieces above that fall right down to kind of fill in that spot. So it adds a little bit of challenge, especially if you're going for those Tetris line clears. You could be kind of building something up and then the game forces you to sacrifice something. So I think it leads to some kind of interesting gameplay. And if you really want to get a sense of what this game is like, I have great news for you. You can go play the game yourself right now. I will leave a link to the game in the description below. You can just play it right in your web browser if you like. If you're on a Windows PC, you can definitely download the game if you'd like to do that. However, if you don't have the means or desire to play it, you can definitely watch the Let's Play video that I made of it, where it's basically me just kind of playing the game and kind of talking about some of my initial thoughts after I made the game. So if you enjoy this postmortem at any point, make sure you leave this video a like and feel free to subscribe to the channel for lots more really cool independent video game development related content like this one. And if you have any questions or comments for me, feel free to drop them down in the comments section below. But with all that being said, I think we should get into the actual postmortem of the video. So the way I'm going to structure this video is I'm going to talk about some of the things that I learned while making Tetris, because it is mainly a Tetris clone with a little bit of my own twist on it. And then I'm going to, of course, talk about some of the things that went right during the development and some of the things that went wrong during the development of this game. So what did I learn while making the game Tetris? I learned that making the game Tetris is very difficult, especially during a 48-hour period. When I went into this game jam, and I kind of wanted to make something a little bit more puzzly, and the theme dropped for Sacrifices Must Be Made. I kind of thought, maybe it would be an interesting idea to make a little bit of a Tetris clone and somehow work sacrifice into there. I was like, Tetris is a pretty simple game to make. There's just kind of blocks falling and they spin around and, you line them up and it should be pretty easy, right? No, not exactly. Tetris is a pretty difficult game to make. There are a bunch of different considerations for things that you have to account for. Some of the things seem a lot easier than they really are, and so I'm kind of just going to go over the list of some of these major things right now. So the very first challenge you need to figure out is how you want to make your board. Your Tetris board is going to be a 10 by 20 grid, and you need to make sure that your game can kind of keep track of where pieces are on the board and everything. So that's pretty simple. This is just kind of the first thing you need to consider. The next thing is actually spawning pieces. Again, not too difficult. You kind of just spawn the piece, and then you need to make sure that that piece knows where the other little tile pieces are in relation to it. So again, that's not all too difficult. The next thing that you need to consider is how you're actually going to move the pieces. In Tetris, you can press the down arrow to kind of step it down, and you can push the side to side arrows to move the piece side to side. And then of course you can hit the up arrow and it sends the piece all the way to the bottom. So again, this is fairly simple. It's just a matter of checking to see if the piece can be moved down or to the sides, to see if the piece will stay in bounds or if there's another piece in the way. and then you actually move the piece in the direction that you'd like to. So it's starting to get a little bit more complicated, but again, that's not all too difficult. Now, where things actually start to get a little bit more challenging is when you actually want to go ahead and rotate the Tetris pieces. Now, there are a number of ways that you can accomplish this, but for me, in this kind of game jam, I kind of treated this as an exercise to make a real accurate version of Tetris, just to really kind of learn the inner workings of it and everything, because I think Tetris is a really fun and addicting game, and I kind of want to know what goes into actually making the game. So the way I did it is all of the pieces basically have like a center origin point, and then when you rotate the pieces, they rotate around that point. And I found an excellent video online that explains how you can make these rotations happen. It doesn't go into the coding of it, but it goes more into the mathematics side of it all. And I'll definitely link to that video because it really gave me a good way to kind of visualize the whole process of what's happening. So essentially what you need to do is for each little tile piece that makes up the one piece that you're trying to rotate, you need to convert that piece's global coordinates on the overall board to coordinates in relation to the origin piece. So if you think of the origin piece being at 0, 0, and then one piece above that would say be at 0, 1, even though it's kind of at some random spot anywhere on the board. Now the next thing that you do is you actually perform like a matrix rotation operation on it, where you kind of multiply the coordinates of that by a specific matrix based off of whether you're rotating it clockwise or counterclockwise. And then you'll get the relative coordinate points for that tile in relation to that origin point, and then you can convert those relative units back into global overall units. And so that works pretty well for the most part, except for the case of the square and line Tetris pieces. Those don't rotate perfectly because there's not necessarily like a center piece that they will rotate around. So there's an additional offset that needs to be made for those, and I'll be going into those in just a little bit. But as you may be able to tell, this was kind of the first part that really challenged me. It was something that was pretty difficult for me to figure out on my own, and I wasn't getting super far. So luckily I did find some resources online that sort of explained the theory behind it all, and once I understood that theory, I could actually implement it into the game. And I was super happy once I got that part into the game, because that's obviously a key part to the game of Tetris. However, we're not quite done with rotations because there are still a bunch of things that you need to keep in mind for rotations. Now, so the first thing that I mentioned before is, what about rotating the square and line pieces? Because they don't necessarily have a centerpiece, how do you get them to rotate properly? So you notice the square, when you rotate it, it doesn't really move. You can hit the rotation button as much as you want, and it just stays right there. Obviously, it's just 4 pieces, and if you think about it rotating, it's basically going to be the same. However, in this implementation, I have to have the corner piece basically be the centerpiece. So if you rotate it around the corner piece, now your piece is going to end up here, and then you rotate it again, your piece is going to be off to the side. And so we don't want that to happen. So in the case of that, we have to start doing rotation offsets. Now for these rotation offsets, you basically have to keep track of which rotation position they're at any given moment. So obviously each piece has 4 different rotations that it can be. So each piece spawns at the position 0 rotation, and each clockwise rotation that you do, it'll increment that by 1. So it'll go from the 0 position to the 1 position to the 2 position to the 3 position, and then back around to the 0 position. And then if you want to go counterclockwise, you go the other way. So you start from 0, and then you go 3 to 2 to 1 and back to 0. So that's not all that difficult to keep track of. You just need to do a little bit of mathematical operations with the modulo operator in C#. Now the reason you need to keep track of which rotation position it's going to be at is because for every position that it's at and that it's rotating to, you need to have different offset values for. So again, in the case of the square, if we're, say, rotating it from position 0 to position 1, we're going to need to offset it down. However, if we rotate it from position 0 to position 3, we're going to need to offset it to the side. So if you think about it, there's going to be 8 different cases that you need to account for each rotation, because from any given position, there are 2 different positions that it can rotate to. And I found online someone came up with a very clever solution to this problem. So for every rotation position that your piece can be at, it's assigned like a little value to it. So when you want to rotate a piece, you take the value from the position that it's at and then subtract that from the value of the position that it's going to be at. And then that gives you another value. And then that value is going to be your offset value. So this probably doesn't make that much sense in the brief time that I explained it in the video. So I'll definitely leave some resources in the description below of some things that I found helpful, and you can go ahead and read through that if you'd like to. Now, these offset values apply to much more than just the standard square and line Tetris pieces. They apply to all the other Tetris pieces, and you can use this to your advantage to do some things called rotation kicks. So, just as a small example, let's say we have a piece right up against the side of the wall, and when we want to rotate it, some of the pieces are going to be off the grid, and so we can't have that happen. Now, with these rotation kicks, there are a bunch of tests in place, and then basically it tries to move the piece around in a couple of different positions, and then if it fails that test, it'll move to the next one and the next one and the next one until it finds an offset where the piece can be, and it's not off the board or overlapping with another piece or something like that. And then if all the tests fail, then the piece just is not rotated because a rotation cannot be made. And with all these tests, you can do a lot of really cool things like different T-spins and stuff like that. Lots of really cool like high-level Tetris play. Where you can kind of like rotate pieces into gaps. So I think it's really cool that my game has all those kinds of features. It was pretty difficult to implement. I did have to like hard code a bunch of values into the game, and that kind of took a while to type all that in. But I was pretty proud of myself that I was able to kind of look at like some of this theory stuff that was shown online. And then I was able to implement it into my game. I didn't like copy any code or anything like that. I did take like these test values from the internet and implement it into my game, but there's no way I would have been able to figure out all those values myself. But I definitely say that was the most challenging part of implementing Tetris, is getting all those rotations to work correctly. But again, once I had them in the game, I was super excited, and they all worked like pretty much flawlessly. And then the last couple challenges that I ran into, the first one being line clears. So in Tetris, when you have a full line of pieces, that line clears out and then all the other pieces fall down. So you kind of just need to consider how you actually test for all the lines being full. And then once it is full, how you're going to clear that line out, drop all the other pieces, and then of course account for Tetris line clears. So if you're familiar with the game of Tetris, you probably know Tetris line clears, and that's basically when you stack all the pieces up in such a way, and then you take the long stick piece and send it down, and then you can clear 4 rows in a line. That's referred to as a Tetris line clear. So in my game, you can get Tetris line clears, and you are rewarded for getting such with a little message that says Tetris in all cool Tetris colors. And then the last challenge was, of course, making my own twist on the game. So again, for my game, the way it works is every once in a while, when you're just playing the game Tetris, the game will pause. It'll ask you to sacrifice a piece, and then you click on that, and then all the pieces above that fall down. So essentially the way I have it is every 10 turns, the game will check whether the sacrificing operation can start. And the way that's determined is it looks at all the pieces that can or can't be sacrificed. So the ones that can't be sacrificed are any tiles that are up on the top row. If anything is up on the top row at all, that whole piece won't be able to be sacrificed. Everything else, though, under that is okay to be sacrificed. And so if there are, I think it's more than 2 or 3 of those pieces, then you can do the sacrifice operation. And so if we can, then we're going to turn all those pieces that are not able to be sacrificed, we'll turn those gray. All the other ones will stay the same color, but if we hover over them with the mouse, it'll change the color, letting us know that we can click on that tile. And then lastly, when we click on it, all the pieces will fall down right above it. So for the most part, this all wasn't too difficult to implement. It just kind of took some time for me to kind of figure out how I wanted to get everything set up. And of course, because this is an original idea, I couldn't really reference anything for it, but it seems to work pretty well, and I'm very proud of that. So those were most of the challenges that I found during the making of the game Tetris. and I know that took a really long time, so I just real quickly want to go over some of the things that went right and some of the things that went wrong during the development of this game. So first, I made a complete game within 48 hours, made the deadline, got it submitted, and I'm very, very happy with the result. So that's definitely a thing that went right during the development of this game. So next is that I made a pretty stable Tetris clone. As I've said, Tetris is a really great game that I enjoy very much, and I really just kind of wanted to make this as an exercise for me to figure out how the game Tetris works, and I'm glad that I could use Ludum Dare 43 as an excuse to make this game. And it is very fun and addicting. If you haven't played it, again, I encourage you to go play it, but I definitely cannot take credit for most of the game design of this game because I pretty much copied most of it from an existing game. But just put my own little twist on it, which I do think adds a little bit more interesting gameplay elements to the game. And then lastly, during the development of this game, I got a ton of math and programming knowledge from making this game. As you can tell, me explaining all these different rotations, matrix rotations, and all the rotation kicks and offsets that need to happen. There was a lot of math involved in this game, and programming it, it was a very interesting exercise for me, and I think it really did teach me a lot, and it's definitely going to improve my skills as a game developer moving forward. And so yeah, it was really cool to actually use math to rotate the different pieces instead of just saying transform.rotate 90 degrees. And then now, so what went wrong during the development? Well, basically because I took so much time trying to figure out all these weird different little quirks of the game Tetris, there were a bunch of things that I didn't have a whole lot of time for. So the first is obviously the art style. I mean, the art pretty much kind of sucks. Most of the pieces and the grid art and everything like that, that was all supposed to be placeholder art, but I mean, I was running up so close to the deadline that I literally didn't have enough time to make a bunch of new different squares and stuff like that. So that placeholder art just kind of stuck. So the next thing I didn't have time for was I just didn't have time to put in basic features to the game like scoreboards. Obviously Tetris being a high score based game, it would be really nice to have a high score and even a leaderboard. However, just did not have a whole lot of time to do that. And then lastly, I didn't really have a whole lot of time for play testing the game. There were a couple things that I definitely would have found out with extensive play testing of the game. One is, for example, if you get a Tetris line clear on the same turn as the sacrifice a turn, basically those two pieces of text lay on top of each other and it's really kind of hard to see both of them. So just doing something as simple as, offsetting one or the other would have solved that issue, but that's kind of how the game is right now. And then there were a few other little quirks that I found out about sacrificing pieces, but they're not all too game breaking, so that's definitely a good thing. So anyways, that's going to conclude this post-mortem video for my Ludum Dare 43 game jam game called Tetrifice. I definitely learned a lot about the game Tetris, and I hope me making this video taught you about some of the considerations that need to be made when you're making the game Tetris. If you want to challenge yourself as a game developer, you can definitely go ahead and give your shot at making the game Tetris yourself. Of course, because this is a Ludum Dare game jam game, in the compo section, I have all my source code for this game posted on my GitHub account. I will leave a link to that in the description if you do want to reference that. But anyways, I hope you all enjoyed this video. If you did, make sure you leave it a like. Also, feel free to subscribe to the channel if you have not done so already. Hope you all have a fantastic rest of your day, and I will see you in the next one.